Hello, my name is Matthew Anderson, and this is my Lab 1 for Physics 2, charge tapes. So the purpose of this lab was to create charge tapes and observe their interactions with neutral and charged objects and with each other, to determine the excess charge on the charged tape, and to model the real-world interactions using Python. And for a preview, the charge tape had a net positive charge and therefore had an electron deficiency. So the fundamental principles used for this lab were Coulomb's law and Newton's second law. Um, Coulomb's law because we model the charge tapes as approximate point charges, as their charge is mostly in the middle, and use the law to find their charges and determine the interaction between them. And then Newton's second law was used to balance the forces on the tape, as gravitational force acts downward, and electric force acts upward, and they cancel each other out. So we assume that the tapes are point charges and the charge is at the center. We assume that the tapes are equal in length, and we ignore air resistance. The tapes are the system, and everything else involved is the surroundings. So in the procedures, we fold the tape into a U shape, place it on the table, put another piece of tape over it, and then rip it off to charge it. We observe the interactions of the charge tape with a negatively charged plastic object, which it attracted because the tape was positively charged, and it repelled another piece of tape because they were the same charge. And then we suspended it across a gap to see the interaction with the other tape when it is in equilibrium with gravity. So as you can see, the tape interacting with the neutral object, it sticks to the table. The tapes interacting with each other, they repel. And then the tape interacting with the negatively charged clear plastic, it attracts towards it. And then the tape suspended by the apparatus, as you can see, the bottom tape repels downwards away because the two tapes are the same charge. They're both positive. So here are the calculations. As you can see, we measure the length and width of the tape and then calculate the mass from the density. Using the mass and the gravitational formula, we find the gravitational force, and then we find Q using Coulomb's law and the gravitational force. Then we find the number of electrons and the number of atoms from the dimensions of the tape, the charge of the electron, and the number of atoms, the measurement of an atom. Then using that, we can find the number of electrons per atom to find the charge. And we found an electron deficiency, meaning that the tape is positively charged. Here's the code, as you can see. The first portion is setting our constants, the measurements of the tape, the K constant, the charge of the proton, the separation between the tapes when it is suspended. And there's the code for the various calculations that were shown before, and these are the lines of code that set up the spheres and the arrows to model the force diagram. So as mentioned, the positively charged tape is electron deficient, and the tape is floating because it's in equilibrium with the gravitational force equaling the electrical force, and it repels downward because they're both the same charge, and they're both positively charged. Possible sources of error could come from unequally sized tape and charge, as we assume those to be equal, but they're not actually equal. This is also where discrepancies between the model and the real-world calculations arise. Furthermore, it's difficult to measure the separation distance between the two posts and hard to hold the tape parallel between them. So this could cause some small discrepancies between the model and actual calculations. What if the electrons were positively charged and the protons were negatively charged? What would change about the observations? Nothing would change. Positive objects would just be negative, and negative would be positive. The two tapes would still repel. The tape and the plastic would still attract. Fundamental interactions would not change, as likes would still repel and opposites would still attract. It would just change which one is which. And why was it important to hold the charged tape as little as possible and only hold them on the edges? As opposed to touching the middle? It's because the charge quickly transfers from your hand to the tape and vice versa. The electrons from your hand were quickly moved onto the tape. Whenever I would hold the tape for a second too long, it would attract to my hand, and you would have to redo it. So that's why it's important to handle the tape as little as possible for this experiment. And that's all I have.